Hi, my name is Van Calveit. I'm with Green Mountain Technologies. I'm standing in the compost room here at Peace Naturals and delighted to be here with you all to show you about this earthflow composting system. And we're going to go over today the main elements in the system. This first part of this training is on operations, and then the second part will be on maintenance training, and we'll be taking questions from our studio audience as well. And so looking forward to walking you through this. But the main thing we're going to be focused on here for this first part is the mixing system. And this is the earthflow mixing system. And what it is basically is a auger mounted to a gantry. And so it's what we call a traveling auger. And so the idea with this system is that you've got a automated mixing system that travels this entire vessel. So it's designed to cover the entire vessel and go within about an inch of all of the surfaces, the floor and the walls of the vessel. So it's very good at what it does, at mixing and blending and homogenizing materials. And so a couple of things about that want a little orientation. So this is what's called a continuous flow system. So in that context, we tend to speak in terminology-wise of this is what we would call the load end, and that would be the discharge end. And the convention, and this is actually really important for if we ever need to talk on the phone and I'll be your customer service person, just for orienting with each other. So we typically talk about left and right as if you're looking in the load end of the vessel, which is this side. So left would be this side of the vessel, and right would be that side of the vessel. And it doesn't matter. If I'm standing over there, that's still the right-hand side. This is still the left-hand side. So load, discharge, left and right. Let's see. So a couple of things about the mixing system itself. You've got, as I mentioned, the auger, and the auger is attached to the auger shaft is attached to a stub shaft, and the stub shaft is attached to a 5 horsepower auger motor. And that all is sitting in what we call the travel car. And the travel car goes left to right in on the carriage. So I'm just going through the basic terminology of the system, and this is all really helpful for us to have the same language when we're talking about the system. So travel car goes left and right, and you can see that the side-to-side chain is what pulls that system left and right. And the side-to-side motor is on the right-hand side there, and that motor there is what makes the travel car go left and right. So this is, I mentioned a chain. This is a chain drive system. It's all number 60 stainless steel chain. And so that's the side-to-side chain. And then you can see there's two end-to-end chains that run the length of the vessel. And the end-to-end motor is there on the left-hand side. So that's the end-to-end motor. And then it's hard to see from this perspective, but on the other side there's a 1-inch shaft, and it's a pickup style chain. You can kind of see here on the left-hand side where the chain goes under a roller, up over a sprocket, and then down under another roller, and that's how that operates the end-to-end motion of the system. So, and I'm going to just take questions as we go along. So if you guys have any questions, just feel free to jump in as we go through the system. And I'll start it up here in a moment, and you can see how things work. But I'm just going through terminology right now. So let's see what else. So we've got chain drives. And there's one more smaller chain. Oh, there it is on the right-hand side. You can see there's that little dinky chain we call the power chain. Oh, sorry, I'm telling you wrong. I said it wrong.
It's going to catch you.
That was the quiz. Okay, so sorry. This is the end-to-end motor on the right-hand side there. That's the side-to-side motor on the left-hand side. I'm backwards here. So you can see that shaft coming across the middle, and there's the power chain that drives that end-to-end chain. So that's correct. But why don't we take a look here now at the control panel. And so the electricians have set up 3 shutoffs for us, so I'm going to go ahead and turn those. So there's a shutoff for each of this VFD. Each of these boxes have their own shutoff, and these can all be locked out for doing maintenance. And then there's an e-stop, which I'll go ahead and pull that out to get us power. So a couple of things about the controls, and then we can get things started. So with this system, you've got, as I mentioned, an e-stop. You can press that for emergency stop. Then there's the stop button, which if it's lit red, that's a good sign. That means you got power to your control panel. Then the start button, and when you press that, that'll light green. And then there are 3 mix patterns: load, mix, and dump. And then this says there's different types of cycles: auto 1, manual, and auto 2. And auto 1 simply means that you're mixing once at night automatically. Auto 2 means you're mixing twice a night automatically. And manual is manual mode. I'll show you that here in a moment. So, and then load, in terms of the 3 mix patterns, you've got a load program that really just mixes the front half of the vessel, essentially. The load side. Mix mixes the entire vessel, and dump mixes the back half of the vessel. So for your application, I imagine you're going to be in load program almost all the time. So, and then this last part is the joystick, and then you can see that the joystick is labeled front, back, left, and right. So front referring to the load end, back to the dump or discharge end, and left and right, just like we discussed. Okay, so we'll start it up, and we're going to put it in manual, and press go. So it's in manual mode. So when you're in manual mode, all it's going to do is just turn the auger, and it's just waiting. So then if you want to make it go in any direction, you can use the joystick in the manual mode. So if I go to the left, it moves the auger to the left, and now to the right, and then now to the front, and now to the back. So that's manual mode, and then I'll show you a little bit of auto mode. So let's see here. So right now I'm in the load program auto 1, and so this is what it would look like under normal operation. It's going to be moving. Typically in the load program, what it's going to do is head towards the load end of the vessel, and it goes side to side. So it'll just kind of do like a Z shape or a zigzag pattern. It'll go back and forth, left to right, as it's heading towards the load end. These are basically the do's and don'ts. Every system has its strengths and weaknesses and its limitations, and this is the part where we kind of talk about those things that to avoid with the system in order for it to function smoothly and trouble-free for you, and for the warranty to remain valid. So key operations requirements include doing the preventative and maintenance schedule, which I'll show you here in a little bit. So doing the PMs on the system. Avoiding overloading the system is a really important thing. So an example would be getting the system so full that you're getting compost or feedstocks up onto the rails or into the mixing system. Really bad for the system and increases the risk that it can malfunction if it's got a bunch of compost in the actual mixing system. So you want to keep the compost. A good measure is you can see that there's these horizontal bars, stiffener bars on the bottom of the carriage rails that are sticking down there. They're about 5 inches wide. You want to keep the compost below those bars, and that's a good general guide that you're staying out of trouble with the height of the material. Another item is avoiding long fibrous materials, and this is the main reason why there's a plan for, as I understand it, for a shredder to be here to shred up the stem so that it's not. If you put long fiber material in the system, the auger is great at grabbing material like that and just wrapping it around the auger. Then you guys will have to get in there and cut it off, and it's kind of a pain. So avoiding string, long fiber, tall weeds, plastic bags, things like that don't play well in the system. Other things that are not good to put in the system: rocks, branches, or other large items that can damage the system. I know that you're going to be putting, or is my understanding, you're going to be putting root balls in the system. And just know that any kind of mineral aggregate in the system is going to wear on the auger flighting more quickly. It basically, if you put mineral in the system, it basically acts like a sandblaster on that auger. We had one client that they were doing dairy cows, and they were bedded in sand, and then that was all going in the system, and they were going through auger flighting about once a month. So even though this is hardened stainless steel flighting, it'll just whittle it like a pencil. So just know that the auger flighting is intended to last 1 to 2 years before it has to be replaced, but mineral aggregate will shorten that lifespan. Let's see, preventing risk of fires. If you get compost overly dry, it potentially can either spontaneously combust or generate dust and sparks that can cause a fire. So really important to keep the moisture content in the system above 35%. I don't see that as being a problem with your feedstocks, but we'll talk about moisture content measurement. And the other piece is aggregate bulk density. That's a technical term to just mean how dense the compost is that you're putting in the system. So you want to keep your aggregate bulk density in the system below 900 pounds per yard. In other words, a 5-gallon bucket of the mixed feedstocks should weigh less than 22.5 pounds. If you fill a bucket up to the rim and then tamp it down and fill it up, it should weigh less than 22.5 pounds. If you put material in there that's heavier than that, like for instance, an example would be like soil or clay or something like that. It's just like the system's like trying to mix cookie dough, and it'll stress the system out. So definitely that's another warranty requirement, is to keep that bulk density below 900 pounds per yard. Again, for the feedstocks you're planning on putting in here, I don't think this is a problem at all. And then the last thing I want to say is safety issues with respect to the system. So we have mechanical safety issues that I brought it to folks' attention, but I want to emphasize that mixing auger as well as the chain drives. Obviously the mixing auger is hazardous to be around. There's also pinch points on the chain drives on the end. So I recommend that we make sure that there are safety protections around this system so that people can't get unauthorized access into that mixing system, because it's not to be messed with. So needless to say, no reaching in, no leaning in, no standing on the rails while the system is running at risk of getting too close to that auger. So long hair, scarves, things like that would be problematic. So we'll want to talk about, and I know that there's plans in place for that, but just making sure that there's good safety protections mechanically. And then also there's electrical safety issues, mainly here in the panels. We've got 3-phase power here, so we've got some significant voltage, particularly in the variable frequency drives. So using standard protection for that hazardous voltage. And then, as I mentioned, there's lockouts available on these switches, so that it's possible to lock out the system for doing maintenance. Questions so far? Let's see here. Let's talk about checking moisture content. I mentioned that, so this is on page 10 of your handout. We've talked about manual mixing, and we'll go through some of this, and you can try some of these things yourselves. Moisture content, the really simple way to measure moisture content first is just by eye. If the material is looking dusty, that's typically your sign that it shouldn't be looking there shouldn't be dust in the air when the system is mixing. When the compost is at the right moisture content, it's described as having the moisture of a wrung out sponge. Like if you take a sponge and you just kind of squeeze most of the water out of it, that's the right moisture content. A dry sponge would be an example of too dry, and too wet would be a sponge that you haven't squeezed yet. So when you squeeze that compost, it's just like squeezing a damp sponge. You should be able to get some water to drip out for you. It shouldn't stream out, and it shouldn't be no water in there. So same thing, you can just get a plastic bag or a glove, or you can do it with your bare hand if you want, and grab a handful of the compost, squeeze it. You should be able to get a few drops of water to drip out of that. That tells you that you've got a good moisture content if you can get a few drops to come out. Does that make sense? Okay. You can also, if you want, weigh a wet sample and then put it in a microwave or in an oven, dry it completely out, and then weigh it again to measure how much water was in there. And that is on page 11, in case you want that. Those instructions are there for you if you want to get more exact in terms of measuring your moisture content. Fine. Unloading compost. My understanding is the plan is to essentially come in with a bucket loader and to take a bucket of compost at a time and just empty it out. So for doing that, you could just bring the gantry all the way to the load end and then empty it out. Pretty much you can empty out the entire vessel. And it'll be up to you whether you want to empty out part of it at a time, like take half of it out every so often, or empty the entire thing and start over again. It works fine either way. We ready? So this is the maintenance schedule. There are weekly inspections, monthly inspections, quarterly and annual. And pretty straightforward. I'm going to go through starting with the weekly inspections, what to be doing on the system. And so just going through the weekly inspections, visually inspect to ensure the mixing system remains clear of foreign debris. Remove any foreign debris from the system. Just like we talked about before, you can use an air compressor to blow off the rails if there's anything got on the rails or into the chain drives. Pretty straightforward. Visually inspect the carriage to ensure it is square to the vessel. And this is something that we talked about a little bit before. One of the things that we're still doing some testing here today, but generally speaking, what we're doing is that we're wanting the carriage itself and the carriage rails to be square with these chain tensioner plates on the end of the vessel. And so typically what I would do is bring the system to the load end. We can do it from the discharge end as well. And we'll just go and do a demonstration of this and measure from the inside of the plate to the rail itself and square up the system that way. And probably to do this right, I should show you we should switch to the other side to show you this part since we're closer to the dump end. Can we do that? Take the measurements. So what this is just the truth about this system. And I'm still haven't quite determined if this is the concrete wall or the rails. I know that the rails are pretty parallel with the concrete wall. So it looks like the system is 2 inches out of square. Like the two perpendiculars on the system are 2 inches out. So what that means is that while the rails are parallel with each other, the system is slightly a parallelogram rather than a rectangle. So what that means is that when you're measuring here, if you want to measure from this rail to the inside of the chain tensioner bracket. What do you have there? 67? 67, okay. And then let's measure the other side. $65. And that is my suggestion of where you're going to want to be. You're actually going to want to have the system about 2 inches, so it's going to look a little weird. But when we tried to square this up so it was the same, the carriage didn't want to do that. It literally moved back. So that's the spot that it's happy in, to have it 2 inches further on that side than on this side. So it'll run nice and smooth for you, but that's just the reality with this system. That it's going to, you're setting it to 2 inches. It can be as much as a ½ inch out of that whack with that, so as much from 1.5 inches to 2.5 inches out, and it should be fine. But you want that your 2 inches is going to be your center of gravity there, or where you want to be. Which is, when you first start up this system, there is this what we call a startup period, where the first 3 to 6 months of operating this system is the most important time to really be on the ball from a maintenance standpoint, because the system's getting used to being under load, chains are doing stretching, bolts can work themselves loose, and so what we'll want to do when you go live here is we'll want to have some regular conference calls, typically every other week, to just check in, answer questions, just see how it's going. We've really found that it would just get the system through that first 3 to 6 month period, and then it runs really smooth and reliable after that. But while it's getting started, we want to make sure we establish those good habits for preventative maintenance, and that we're being in close contact for that startup period. Let's see, and the next item I have is inspect the tension on the side-to-side chain and adjust tension if needed. And I can see already here probably we want to tighten this. I'd probably hate to do this, but it would probably be best to go back to the other side. So these nuts here, there's 2 jam nuts on each side for adjusting the side-to-side chain tension, and we'll want to tighten this up a bit. Especially what you're looking for here is this droop on the left-hand side in particular. And what you're wanting to avoid is where you're getting so much droop on that chain where it's going to want to slip a tooth on the sprocket. So you're just keeping it snug enough so that it's not going to be vulnerable to slipping. So simply you can loosen one of the nuts, and then typically you're just tightening the chain up. And as the chain stretches over time, which it will, that's going to be a part of the weekly inspection, just going in and snugging that side-to-side chain up. So that's the story there. This power chain is nice and tight. Eventually it will stretch over time, but it'll take longer, but that's pretty darn good. So that's, and then physically inspect the carriage rails. So these are the carriage rails right here. And the system, if you think about it, is doing most of its work in this side-to-side motion. It's going back and forth and back and forth. The end-to-end motion is pretty slow relative and is a lot less. So this is the part of the system that's undergoing more abuse and more wear and tear. So we're going to want to keep these rails lubricated. You can use there's lithium grease on there now. That works just fine. We've also used red grease in the past, other types of spray lubricant, but the lithium works fine. And you're going to want to lubricate. You can see where I've lubricated on the inside of each rail face. And then you can see in here there's slide blocks that are facing each of the inside of the rails. And then there's an additional set of slide blocks on the underside of the rails down here. And so you want to lubricate the underside of the rails as well. And since we're under here, I'll also show you these brackets. This is, we call the undercarriage support. So this is basically what keeps that auger from bucking off of the system. If it didn't have that, it would jump all over the place while it's under the load of the compost. So you can see here there's these adjuster bolts. These are designed to adjust the height of that bracket. And then there's these bolts here on each side that tighten that down, and they're actually doing the job of holding that bracket in place. So if you want to adjust the height of this entire bracket, then you'd loosen these two big bolts here, and then you can adjust the tension on these tensioner bolts to set it at the right height. And the right height for this is you're wanting these black slide blocks to just be kissing or touching the underside of the rail. You don't want, if you could make them so tight you could keep the thing from running at all. So it's just you're wanting it to be touching the underside of the rail and not any significant gap there. There is a spare parts kit, which I don't know if you've seen that. Well, you just moved that outside. So that includes a spare set of those square slide blocks as well as these slide blocks on the inside of the rails. So eventually they'll wear out and you can replace those. So that's the story there. Also a note here on the travel car, these track rollers. There's one of these in your spare parts kit as well to replace these over time. And let's see, where are we at? I'm looking back at the monthly schedule. So if we look to the monthly inspection, it's basically a more in-depth version of the weekly inspection. So it includes squaring up the carriage. It's looking for kinks or overstretching of the chain, checking the tension of the side-to-side chain, adjusting tension as needed, checking tightness of set screws on sprockets for the end-to-end drive and both drive motors. So making sure all keys and set screws are secure. So why don't we walk through those? So let's see, what's the easiest one to get a look at? Maybe over here. So you can see there's these sprockets on the end-to-end have set screws, and keeping those tight so that those aren't at risk of trying to work their way off of the shaft. But now we've got a good look at that pickup chain. So you've got the chain coming underneath the roller here, up over the chain and back down under another roller. And this is that shaft, drive shaft that's driving that end-to-end motion on both sides. And so keeping an eye on those set screws. There's also set screws here on this sprocket, although this one really can't go very far. It's on the shaft. The keys are welded in place, or I think in this case they're actually tacked in place. And then that's another set. These are other set screws to check on for the end-to-end motor, and the same thing on the side-to-side motor. Tightness of nuts and bolts on travel car and motor mounts. So let's take a look at that. So you've got on the travel car and the motor mount, I mentioned the bolts underneath on that under support. You also have the auger is adjustable in angle, and we have it tipped back as far as it will tip back. And that seems to be set at that seems to be the best height in this case. But we tightened these up yesterday, but keeping an eye on these 3 sets of bolts per side. This one here, this one, and then there's one at the bottom. So 3 bolts per side of the travel car. Let's see, what else? The motor mount bolts, of course, on the auger motor. One of the things we're going to do a little later today when we're doing our further testing is just making sure we've got good alignment on the auger motor with this bearing. And guys, I want to show you this auger bearing for the auger itself. You can see it's up underneath there. There's the grease point there for that. And then there's this block that's there to keep compost from getting up into that bearing. So if you ever have to replace that bearing, you'd have to take the auger shaft off, and then you can pull the screws that are holding that plastic plate in place, and then you can replace the bearing. There is an extra bearing in your spare parts kit as well. What else was I going to say about that? When you're doing that, it's you can, if you ever have to take the auger off, what you can do is you can pull these top bolts out, and the auger will tip back even more and lay against the travel car. So it's a lot easier to get the auger out if you have to do that. So let's see. Inspect limit switches. So let's go look at limit switches. Maybe we should go back on the other side. Yeah, let's go back over here. So these are the limit switches here. This is for the end-to-end. One of the end-to-end limit switches here on this side. There's another one on the other side of the carriage. And then this is one for the side-to-side limit switch here. And then there's another limit switch for the other side as well. Yep. Keeping fans, so keeping the vents on top of the auger motor clear of debris, and here as well on the motors, just keeping those clear so that the motor can operate properly. Cable. So this we've got two different cable carriers here. This is the end-to-end cable carrier. So one of the things we want to do, and I was just noticing that this is was kinked up here. It was like sitting up high for some reason. So we want to look and see why is it doing that. It should be sitting nice and flat. So it might be one of those pieces not snapped in all the way. So we want to keep an eye on that. So the big thing with the end-to-end cable carrier is we want to make sure that there's nothing it can snag on. If that cable carrier is able to snag on something, the system of course doesn't know that, and it'll pull itself apart. So we want it all looks nice and clear to me, but that's something just to keep an eye on, make sure that's clear. Here's the side-to-side cable carrier. Simpler and smaller, but same basic situation. I bent the edges of the cable tray out a little bit so that that's not getting in and you're messing around with your cable carrier, but just keep an eye on that area, particularly as it's passing back and forth, and making sure that there's nothing that will interfere with the cable carrier movement there. And let's just go through all our grease points. So you've got these Mariner bearings, one on each end. There's a grease point there. And then these flange bearings, or these pillow block bearings. I can never remember which is which. Well, that's a flange bearing for sure. That's pillow block. So there's another bearing there, and then another one here on this side as well, and then the main pillow block bearing for the auger. Let's see, and then lubricating, you can see I've added some grease on the rails for the end-to-end motion and the chain as well. It's stainless chain, but certainly doesn't hurt to lubricate that chain. Is a good thing to do and is a part of our recommendations. If you're generally if you're hearing noise with this system, that's generally an indication if it's squeaking, if you see the auger will sometimes do this kind of stutter, is typically an indication that either that under support block is not adjusted properly, or that there's not grease on that rail, because otherwise it should just operate smooth. So if you're hearing chains popping, like on the end-to-end, that's generally, you shouldn't hear chains popping. If something's popping, it's probably out of alignment somehow. So generally quiet is good with this system. Piece is to inspect this auger flighting, and we've seen the auger flighting, even though there's lock nuts here on the back, so it's basically it's a nylock on the bottom, and then a hex head on the top. So they should stay nice and tight, but they inevitably work themselves free in the compost. So it's good occasionally to bring that auger out of the compost to the dump end, take a look at it, and make sure that that auger flighting is staying tight. So that's listed as a quarterly item. Out of them. And then every 1 to 2 years, empty the vessel and look for rocks, scrape it out the vessel. You may very well be doing that more often than that, but that's what we recommend. And then every 1 to 2 years inspect these end-to-end slide blocks for wear as well. These will wear down the slowest of the slide blocks, but every 1 to 2 years give those an inspection. And that's it. Well, the lubrication is, I think it was typically monthly for pretty much all of the grease points, and is what the schedule lists, but also just as needed. You know, if you, like you say, if you're hearing squeak, if it seems like it's getting squeaky on you, then do the lubricating at that point. Any other questions?